Today's lesson is sports biomechanics, and the graphic you see in the middle is a high jump technique called the Fosbury flop, which was actually developed by an American, Dick Fosbury, back in the mid 60s. Now, it used to be the technique was you come up, you jump, and you straddle the bar as you go over. But he developed this technique and was very successful, and then everybody copied that technique. Now it's the standard technique for doing the high jump. The two main benefits of sports biomechanics are injury prevention and performance enhancement. Now, when we look at injuries, most injuries in the body occur because of some type of imbalance. So if we use biomechanics to look at the muscles and how they're interacting with our bones and how the joints are moving, make sure those are moving properly in their proper ranges of motion, that can help reduce the chance of injury. Performance enhancement, you saw in the title slide, the Fosbury flop. Once people found that technique worked better, they used that. So trying to figure out what are the best techniques or movement that are going to give us the best quality of movement. Sport biomechanics are beneficial to coaches and athletes because everybody's bodies are different, then also the different sports have specific needs. So the different bodies and the specific needs of the sport can determine how they're going to use sport biomechanics. So we mentioned before that injury prevention and performance are important, but coaches and athletes can also use it to analyze sports movements, to select the best training exercises, and then also to design or choose the best sports equipment. These are all factors that are going to help the athlete's performance in that sport. They could also incorporate a couple other areas that can help: sports science and kinesiology. Sports science is the study of how the body works. If you see in the graphic on the right, it looks like the person's running on the treadmill and they're probably doing a analysis of the oxygen uptake. And then kinesiology is the study of human movement. So kinesiology is going to combine physiology, anatomy, and with biomechanics, and look at that to see what might be the best way for the athlete to incorporate all those different things. Examining the areas of sports biomechanics study, this is basically a review of the topics we've talked before in this unit. And first we have the laws of motion. Our good buddy Sir Isaac Newton came up with 3 laws of motion. Most sports involve some type of movement, so that's important. Again, the first law is law of inertia, the object at rest or moving. Second one is acceleration. Again, the force pushing you in the direction of the mass acceleration. And then also reaction and opposite reaction. So there's equal reaction, action, and reaction in the third law. Mechanical principles, balance, center of gravity, transfer weight, all those things are important for our performance. We look at principles of force. Our weight and our mass are big factors in the force generated. So it's important to see those relationships. Projectile motion, most sports have some type of projectile. For example, if you're throwing a baseball, it's going to have a vertical and horizontal component to it. Also, the athlete's body can be a projectile. And then core stability, all movements based off our core. So it's important that those muscles in our core, from our chest down to our hips, front and back, are strong and also balanced and aligned correctly. If we look at posture too, that's important for our core to function effectively and then have efficient movement. Let's look at some examples of specific sport biomechanics that people might study. In baseball, they might look at the throw itself. So there's a lot of factors that go into that: the stride length, the torso rotation, the grip, and the release point, and the summation of the force from the lower body to the upper body. Those are things they might look at in biomechanics as far as a baseball throw. Flight of a soccer ball, we would look at the plant foot position, our body angles, okay, especially of the leg, our kicking surface, okay, where we're making contact with the ball. Those could all affect the flight of the soccer ball. And then volleyball hitting forces, we will look at the vertical part of the jump versus the horizontal forces, the height and extension, and the follow through, so how much force we can create when we're hitting the volleyball. Summarizing today's lesson on sports biomechanics, the two main benefits of sports biomechanics are injury prevention and performance enhancement. Now, coaches and athletes can do some other things with sports biomechanics that will be helpful for the athletic performance. They can analyze the different sport movements. They can select the best training exercises. They can design or choose sports equipment that best matches the athlete's needs. These are all things that can help with that performance. They can also incorporate some sports science and some kinesiology to help out. Some areas of study we talked about before, looking at the different laws of motion, mechanical principles, different forces, projectile motion, okay, and then your core stability. Those are all going to impact the athletic performance. Lastly, we looked at some different examples like a baseball throw, a soccer kick, a volleyball hit, and how they might look at it differently from a biomechanical point of view to analyze those sports. So for you, think about your individual sport activity and how could you analyze your activity to help you benefit your performance. What are some areas that you feel for your sport that could be analyzed well and broken down to improve your performance?